This is 3.2 graphs of equations. We're going to be sketching graphs using the point plotting method and finding x and y intercepts and using them to help us sketch. This point plotting method is kind of like a last resort method if you're unsure of how to graph something. But we start off with it. It's our first method of graphing because it can be used anytime, anywhere. Okay, so we're going to learn later in chapter 3 different methods for graphing, but they only work in certain forms or certain circumstances. So this point plotting method works all the time. That's why we teach it first. So some guidelines here. If possible, rewrite the equation by isolating one of the variables. So typically we want to get y by itself. Sometimes you can get x by itself. Next, we want to make a table of values showing several solution points. So those are points that we can graph. And then we're going to plot these points on the coordinate plane. And then connect the points with a smooth curve or line. So play connect the dots. So let's start off with the graph of 3x minus y equals 2. If we can, we always first want to solve for y. So if I'm going to solve for y, I need to get y by itself. So the thing that's bothering y is this positive 3x, right? And to undo a positive 3x, remember I want to move the whole thing. So if I subtract 3x, what that's going to end up doing is zeroing those out. So what's left is a negative y. And over here, a 2 minus 3x. Those aren't like terms. Okay, so I can't turn this into a negative 1x. I can't combine them because they don't both have an x. So I'm just going to write down my minus 3x and my positive 2. One more thing to get y by itself, there is a hidden negative 1 here. And y is being multiplied by that negative 1. So I'm going to divide by a negative 1. And if I divide on that side, I need to do it by everything over here. Okay, so the negative 1s will cancel out. A negative divided by a negative will turn that into a positive 3x. And a positive divided by a negative will turn that 2 into a negative. Okay, so I've solved for y. Next, I'm going to create a table of values. So what that means is, again, we want to plug in for x and solve for y into this equation. So now it becomes 3 times this x value is negative 2 minus 2. And remember that pops out the y. That's going to be equal to y. So that'll be a solution point, the y value. So 3 times negative 2 is negative 6. Minus 2 would be negative 8. That's the y value, but the x value that we plugged in was negative 2. And then you keep going for negative 1. So it would be 3 times negative 1 minus 2. And that's the y value. So negative 3 minus 2 is negative 5 when I plugged in negative 1. Plugging in 0, I'd get 0 minus 2, so negative 2. And 0 was my x value. 3 times 1 is 3, minus 2 would be 1 when I plugged in 1. 3 times 2 is 6, minus 2 would be 4 when I plugged in 2. And lastly, 3 times 3 is 9, minus 2 is 7, and 3 was my x value. So I have 6 different solution points here. The last step is going to be plotting them. So negative 2, negative 8, just like in Battleship. Negative 1, negative 5. 0, negative 2. 1, 1. 2, 4. And 3, 7. Okay, so I plot the solution points, and remember step 4 would be to connect the points with a smooth curve or line. this one's not curving at all, it's a straight line. We can put arrows on the end to show that this line goes on forever. I could pick an infinite amount of x's and I'd get an infinite amount of solution points. Okay, this time I have negative x squared plus 2x plus y equals 0. Okay, well I can solve for a variable if I'd like to follow those steps. So typically we like to solve for y. So if I'm going to solve for y here, there's two things bothering it. Right, a negative x squared and a 2x. So let's move the negative x squared over by adding x squared. Those would zero out. Drop down your 2x plus y. 0 plus x squared is just x squared. Now to undo this positive 2x, I'm going to subtract it. Those would zero out. Now I'm left with y equals. These are not like terms, okay? They have the same variable, but they're not raised to the same power. So positive x squared and a negative 2x. I can't combine them. All right, now that I've solved for y, remember step 2 is to create a table of values. So I'm plugging in negative 2 for both spots on the x. So it says to square the negative 2 and subtract 2 times negative 2. Okay, remember order of operations when you're doing this. Negative 2 squared means negative 2 times negative 2. That would give you a positive 4. Okay, so you have a 4 minus 2 times negative 2. So a negative 2 times a negative 2 would be a positive 4. So now it's 4 plus 4 and you get 8. Remember that is the y value. Okay, y is equal to whatever you plug in x. Here we plugged in negative 2. Okay, so that's one solution point. And then you keep going. All right, this time take negative 1 and square it. Minus 2 times negative 1. Negative 1 squared is 1. Negative times negative would be a positive 2. And then 1 minus 2, you'd get, well, we plugged in negative 1, and we got out a negative 1. Try 0. Zero minus 0. When I plugged in 0, I got 0. Go ahead and do 1. When I plugged in 1, I got a negative 1. And keep filling in the rest of the chart. So I know that this is tedious, and that's why most people don't like to use this method. But it is, like I said, used as a last resort in some cases when you don't have anything, any other method that you could possibly use. Three squared is 9, minus 2 times 3, so minus 6. So when I plugged in 3, I got out 3. And the last one is 4. 4 squared is 16. Minus 2 times 4, so minus 8. When I plugged in 4, I got 8. Okay, I'm ready to plot my solution points. On WebAssign, you will have to fill in charts like this, and you will need to graph. So negative 2, comma 8 is my first point. Negative 1, negative 1, 0, 0. Oh, I messed that up. Sorry, folks. The part that I messed up was over here. A negative 1 squared is a 1, but I have a negative 2 times a negative 1, so that would have been a positive 2. So 1 plus 2 here should have been a 3. Okay, so negative 1 comma 3, and then 0, 0, and then 1, negative 1, 2, 0, 3, 3, and 4, 8. So this one isn't a straight line. It looks like I'm going to have to curve my graph. And we call this shape a parabola. So pretend that that went through that point. Something I want you to notice is the exponent on x in the first example was 1, and we got a straight line. The exponent on x in the second example was 2, and we got a U-shaped line. So let's see what happens when we have an absolute value. Well, it's already solved for y, so I can just start plugging in values for x. So I'm finding the absolute value of negative 2 minus 2. That means it's the absolute value of negative 4. So y would be positive 4 when I plugged in negative 2 for x. Do the same thing with negative 1. The absolute value of negative 3 is a positive 3. And I plugged in a negative 1. The absolute value of 0 take away 2, so the absolute value of negative 2 is a positive 2, and I plugged in 0. Absolute value of 1 minus 2, so that's the absolute value of negative 1. So when I plugged in 1, I get a positive 1. Do the same thing for 2. The absolute value of 0 is just 0, so 2 comma 0 is the next solution point. 3 minus 2 is 1. The absolute value of 1 is a positive 1. Same thing for 2. The absolute value of 2 is 2, so 4 comma 2 is a solution. And 5 comma 3 is the last solution. I'm ready to plot these points. Okay, so saved a little time there, and after I plot these points, it's a V-shaped. Okay, so an absolute value will always look like a V. Sometimes it'll be straight, sometimes it will be up and down, side to side. We'll learn about those. But a x squared will always be a parabola, okay, a U-shaped. And we'll talk more about those later. Something I want to take note of, they picked these values to plug in, but if we would have picked, just say, the values negative 9 through negative 5, you would have only seen this part of the graph. Okay, so you're not actually seeing it V off. So something I want you to keep in mind if you're graphing these, and you get to pick your own values. Okay, so let's sketch this graph. Here we get to pick our own values. So let's again make sure that we pick 0, we can pick negative 1, negative 2, 1, and a positive 2. We won't do as many as they do. And we want to figure out our solution points here. So when I plug in negative 2, so I have a negative absolute value of negative 2. Well, the absolute value of negative 2 is 2, but I have that negative out in front. Okay, so when I plug in negative 2, I get out negative 2. When I plug in negative 1, I'm getting out negative 1. When I plug in 0, there is no such thing as negative 0, so I'd get 0. When I plug in a positive 1, I get a negative 1. And when I plug in a positive 2, I'd get a negative 2. So let's see what this graph looks like. All right, after plotting the points, you should get an upside down V with the origin spaced at 0. Or not the at the origin is where it V's off. Over here, it V'd off at a positive 2. That could be something to do with inside the absolute value. I don't know, we'll find out later. Okay, so the blank is the point where the graph crosses the x-axis. Where does the point cross the x-axis? What do we call that? We call that the x-intercept. Okay, it's going to be a point a comma 0, right? If I drew this line, it's crossing the x-axis here at 6, or I guess 7. So that is the point 7 comma 0, right? A in this case would be 7. Okay, so to find an x-intercept, we want to always let y equal 0, right? Because when y is 0 here, we're on this x-axis. We're figuring out what number that is. Okay, so the point where the graph crosses the y-axis is called the y-intercept. And this y-intercept up here would be at the point 4. Well, that is the coordinate point 0 comma 4, right? So 0 comma b. B is 4 in this case. So to find the y-intercept of an equation, we want to let which value equal 0? Well, this value right here is the x value. So x equals 0 to find the y-intercept. Okay, so let's try this example. Find the intercepts and then sketch the graph. For the sake of time, we're not going to sketch the graph. Find the x-intercept. Okay, so to find x-intercept, we need to let y equal 0. So I plug in 0 for y. The rest stays 2x minus 3. Now I need to solve for x. So the number bothering the x is the 3. I'm going to add it over. It'll 0 out. 0 plus 3 is 3. And the other number bothering x is the 2. So I need to divide by 2. And 3 divided by 2, you could leave it as 3 halves, or you can put 1.5. Find the y-intercept. We let x equal 0 here. So y stays the same, and then we plug in 0 for x, and we solve, since it's already solved for y. 2 times 0 is 0, minus 3 is negative 3. And if you know anything about lines, which hopefully you do, but we haven't yet talked about in this class, we can always find that y-intercept if it's in slope-intercept form, which we'll get into later. Okay, but what about this? It's not in slope-intercept form, so I want you to try to find the x-intercept and the y-intercept. Okay, hopefully you found that x-intercept is 3 and the y-intercept is negative 2. So to find the x-intercept, I plugged in 0 for y, and I simplified down to get x is 3. To find the y-intercept, I plugged in 0 for x, simplified down, remember to divide by negative 3, and you get negative 2. All right, we'll work more with this on the activity and the web assignment, but please ask if you have any questions.